ሰላም ለእናንተ ይሁን የዚህ ቻናል ተከታዮች። ዛሬ ትናንት በቀጠለ በሁለተኛ ክፍል በዚህ ቪዲዮ ተመልሻለሁ። ትናንት ወርክሺት 2 ላይ የመጀመሪያዎቹን 12 ጥያቄዎችን ለማየት ሞክረናል። ዛሬ ደግሞ እነሱ የቀጠሉትን ሌሎቹን ቀሪ ጥያቄዎችን ለማየት እንሞክራለን ማለት ነው። ጥያቄዎቹ ከ13ኛው ጥያቄ ጀምሮ እስከ መጨረሻው እስከ 17ኛው ድረስ ያሉትን ጥያቄዎች በተቻለ መጠን ለማየት እንሞክራለን። ስለዚህ በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት ያው አዲስ የሆናችሁ ለዚህ ቤት አዲስ የሆናችሁ ተማሪዎች ወይም ደግሞ ልጆች ካላችሁ ሰዎች ካላችሁ ይህንን ቻናል ሰብስክራይብ በማድረግ እንድትጀምሩ አበረታታለሁ። ይህን ካልኩ በኋላ በቀጥታ ወደ ጥያቄዎቹ በምንሄድበት ጊዜ የመጀመሪያው ጥያቄ ይሄ ይሆናል። that means it says use the location theorem to show that f of x equal to x cubed minus 4x squared plus x6 has a root between x equal to 0 and x equal to 1. ስለዚህ ይህን ጥያቄ በምንሰራበት ጊዜ ለዚህ ጥያቄ መልስ ቁልፍ ሊሆን የሚችለው ነገር ምንድን ነው? ሎኬሽን ቴረም ምን ይላል? ወይም ደግሞ ሎኬሽን ቴረም በሁለት ሪል ነምበሮች መካከል አንድ የሆነ ፋንክሽን ሩት እንዳለው ወይም ደግሞ እንደሌለው በምንድን ነው የምናውቅ የሚለውን እሱን ማስታወስ ያስፈልጋል። ስለዚህ እሱን ስናይ ይህን ቴረም እናያለን። ሎኬሽን ቴረም ምንድን ነው የሚለው? if f of a and f of b have opposite signs then there exists at least one root in a and b. That means when a and b are any two real numbers, whether a is less than b or a is greater than b, and if the product of the functional values of this a and b with respect to the given function f of x has a negative or strictly less than 0, so that will be an indication for the existence of at least one root for the given function that is f of x እንዳለው ይጠቁመናል ማለት ነው። ስለዚህ ይህ ፋንክሽን በx equal to 1 እና x equal to 1 እና x equal to 0 ሩት አለ ወይም ደግሞ የለውም የሚለውን ለማወቅ ምንድነው የምናደርገው? we have to check by the sign of the functional values f of 0 and f of 1. If the sign of f of 0 and f of 1 are opposite, then that will be an indication, or the using location theorem guarantee that the existence of one root for this function in between 0 and 1. Therefore, we know that f of 0 is 6. If you substitute 0 in the place of x here, we have this one that is 6, and f of 1 is equal to 1 minus 4 plus 1 plus 6, which is 4. So as we clearly observe here, both f of 0 and f of 1 have the same sign, which are both are positive, so that their product cannot be negative. Therefore, this indicates that since both are positive, there is no sign change. Therefore, the theorem doesn't guarantee a root in 0 to 1. ስለዚህ በዚህ በሎኬሽን ቴረም አማካኝነት f of 0 እና f of 1 ኦፖዚት ስላልሆኑ ሳይናቸው the sign the same that is positive ናቸው ሁለቱም። ስለዚህ ይህ ሎኬሽን ቴረም ይህ ፋንክሽን በ0 እና በ1 መካከል ሩት እንዳለው ጋራንት አይሰጥም ወይም ደግሞ መኖሩን አይጠቁምም ማለት ነው። ስለዚህ ሩት የለውም። Okay. Next question. Apply location theorem to show to determine an interval containing a root of f of x equal to x cubed plus 2x minus 1. ስለዚህ አሁን ቅድም ሁለት ሪል ነምበሮች ተሰጥቶን በእነዛ ሪል ነምበሮች መካከል የተሰጠን ፋንክሽን ሩት አለ ወይስ የለውም ነበር ቼክ ያደረግነው። አሁን ደግሞ ምንድነው using the same theorem, that is location theorem, we are asked just to determine an interval containing the possible root of this polynomial function. ያ ማለት ሁለት ሪል ነምበሮችን f of the ሁለት ሪል ነምበሮችን የምንፈልገው ማለት ነው። ይሄ ምን ይሆኑ ፋንክሽናል ቫልዩዎቹ ኦፖዚት ይሆኑ፣ አንዱ ኔጌቲቭ ሌላኛው ፖዚቲቭ የሆነ ማለት ነው። ስለዚህ ለምሳሌ just if I take f of 1, if I substitute 1 in the place of x here, we have 1 plus 2 minus 5, which is equal to negative 2. And another real number which is different from that of 1, probably which may give a positive number, could be this one that's simply f of 2 to the power of 3 is 8, 2 times 2, that's simply 4 minus 5, this is 7. Then as we clearly observe here, f of 1 and f of 2 have different or simply opposite signs because the first one is negative and this one is positive. ስለዚህ ቫሊያቸው ስንት እንደሆነ አይደለም። አንደኛው ኔጌቲቭ ሌላኛው ፖዚቲቭ ከመጣ so that using the quotient theorem this indicates that f of x will have at least one root in between 1 and 2. Therefore, since the signs are opposite or simply their product, that is f of 1 times f of 2 is negative, that is minus 2 times 7, that means so that the function that is f of x will have at least one root in the interval that is 1 to 2. That means this function will have at least one root which is greater than 1 and less than 2. And this is guaranteed by this theorem, which is location theorem. Next question. Given that 2 plus I the root of f of x equal to x cubed minus 4x squared plus 5x minus 2, then use the conjugate root theorem just to find another root. ስለዚህ ፋንክሽን አለኝ። ይህ ፋንክሽን ሰጥተናል። ለዚህ ፋንክሽን የኮምፕሌክስ ነምበር 2 ፕላስ አይ አንድ ሩት ነው። ስለዚህ we are asked just to find the conjugate root of this theorem. ስለዚህ ኮንጁጌት ሩት ለመፈለግ ምንድን ነው የምናደርገው? ኮንጁጌት ሩት ቴረም ምን ይላል የሚለው ማስታወስ ያስፈልጋል። ስለዚህ ምንድን ነው የሚለው? if a polynomial has real coefficients, that means if the coefficients of the polynomial function are all that are real numbers, and if we do have that simply for the given function, if a plus bi is the root of one of the possible roots of the given polynomial function, then the complex conjugate of this complex number, which is a minus pi, is also the root of the same polynomial function. ስለዚህ አሁን a plus pi እና a minus pi ምንድን ናቸው ከተባለ አንዱ የአንዱ ኮምፕሌክስ ኮንጁጌት ነው። ስለዚህ ይሄ ሪል ነምበር አይ ሚን ኮምፕሌክስ ነምበር ለዚህ ፖሊኖሚያል ፋንክሽን ሩት ከሆነ it is complex conjugate a minus pi must also be the other possible root of the same polynomial function. ስለዚህ ጋር ምንድን ነው የተሰጠን? 2 plus i ለዚህ ፖሊኖሚያል ፋንክሽን ሩት ነው ተብለናል። ስለዚህ የዚህ ኮንጁጌት ሩት ማለት የዚህ ኮምፕሌክስ ኮንጁጌት that means 2 minus i ይሆናል ማለት ነው። Therefore 2 plus i the root of f of x, so that it is complex conjugate root is the polynomial, I mean the complex number that is 2 minus i. Therefore the complex conjugate root of this polynomial function related to that of this one, which is the complex conjugate of this complex number, could be 2 minus i. Okay, if 3 minus 2i is the root of a polynomial with real coefficients, write down its conjugate root and construct a quadratic factor. ሁለት ጥያቄ ልጠየቅ ነው እዚህ ጋር። አንደኛ 3 minus 2i ሩት ከሆነ የአንድ ፖሊኖሚያል ፋንክሽን የሆነ ፖሊኖሚያል ፋንክሽን ኮምፕሌክስ ኮንጁጌት ወይም ኮንጁጌት ሩቱን ፈልጉ ተብለናል። ሁለተኛ ደግሞ using that of the combination of factor and remainder theorem 3 minus 2i እና የዚህ ኮምፕሌክስ ኮንጁጌት ሩት ሁለት ሩት አለው። ስለዚህ ሁለት ሩት ካለው የሁለቱ እያንዳንዳቸው ወይም ደግሞ ፋክተር የሚሆኑበት አለው። ስለዚህ we need to determine the quadratic factor of the given or simply the expected polynomial function. Okay, first the conjugate root is 3 plus 2i, which is the complex conjugate of the given complex number, which is 3 minus 2i. So that using the quadratic factor could be አሁን ፋክተር ቴረምን አፕላይ ስናደርግ 3 minus 2i የአንድ ፖሊኖሚያል ፋንክሽን ሩት ከሆነ x minus 3 2i must be one of the possible linear factor of the given polynomial function. And again, from the conjugate root of the same polynomial function, 3 plus 2i the root of the given polynomial function. Therefore, x minus 2 plus 2i 3 plus 2i could be the other possible linear factor of the same polynomial function, so that the product of the linear factors of the given polynomial function will be the quadratic factor of the same polynomial function. Therefore, እነዚህ ፋክተር ሁለት ሊኒየር ፋክተሮች በምናባዛበት ጊዜ ምን እናገኛለን? This is just we have x minus 3 square plus 4, which can be further simplified as that is, I think, x squared minus 6x plus minus 9 plus 9 plus this one, that's simply 13. X squared minus 6x plus 13 could be the possible quadratic factor of the given polynomial function when 3 plus 2i and 3 minus 2i are it is possible roots. Okay, next question number 14c. If p of 4 is equal to 0 and p of x is equal to 2x cubed minus 11x squared plus 10x plus 8, then find the remaining zeros. ስለዚህ እዚህ ጋር አንድ p of 4 is equal to 0 ይህ cubic polynomial function ነው. that means from the definition or simply property of polynomial function ይህ polynomial function ሶስት distinct roots ሊኖሩት ይችላል. the maximum number of the roots of this polynomial function will be exactly equal with its degree so that ሶስት ሊኖሩት ይችላሉ ማለት ነው። ስለዚህ ከነዚህ ከሶስቱ አንዱ ተሰጥቶናል። p of 4 is equal to 0 ከሆነ 4 could be one of the possible root of this polynomial function. And using that factor theorem, if p of 4 is equal to 0, we know that x minus 4 must be one of the possible linear factor of this polynomial function. ስለዚህ ስናካፍለው using polynomial division algorithm remainder 0 ይሆናል ማለት ነው። ስለዚህ since p of 4 is equal to 0, x minus 4 is the factor of this polynomial function. Therefore, this one that's 2x cubed minus 11x squared plus 10x plus 8 can be expressed as x minus 4 times this quadratic equation. This quadratic equation could be obtained by dividing 2x cubed minus or simply this cubic polynomial function by x minus 4. This is already the quotient. The remainder is already 0 because x minus 4 is the factor of this cubic polynomial function. ከዛ በዚህ መልኩ ፋክተራይዝ ካደረግን በኋላ ሌሎቹን ሩቶቹን ለመፈለግ ቀሪ ሁለት ሩቶች አሉን። those roots could be the roots of this quadratic equation or simply quadratic term 2x squared minus 3x minus 2. So that the root of 2x squared minus 3x minus 2 can be, for example, easily obtained by using that factorization. 2x squared minus 3x minus 2 can be factorized as 2x squared plus 1 times x minus 2 ያ ማለት ይሄን ለመፈለግ እንደምናደርገው ስንደምራቸው minus 3 ስናባዛቸው ደግሞ minus 4 ነው የሚሰጡን ሁለት ሪል ነምበሮች ነው የምንፈልግ so that we can have this one that is 2x plus 1 and x minus 2. ስለዚህ የዚህ ሩቶች ማለት x equal to negative 1 over 2 x equal to 2 አለኝ እዚህ x equal to 4 አለኝ which is given from the question itself. And therefore p of 4 can be fully expressed as in the factorized form x minus 4 times 2x plus 1 times x minus 2. Therefore, the roots of the given polynomial function could be, or the remaining roots could be, negative 1 over 2, the zero of this linear factor 2x plus 1 and 2, which is the zero of the last one that is x minus 2. So that the other roots of, or simply the remaining roots of this polynomial function could be minus 1 over 2 and 2. And third could be, as it is given here, that's simply 4. Okay, next, find a function f such that 1, 2, and 3 are roots with multiplicity 3 to 1 respectively. That means 1 is the root of the given polynomial function f with multiplicity 3 times. 2 is also the root of the same function with multiplicity 2, and 3 is the root of this one with multiplicity 1. And therefore, we just root with multiplicity means a root r with multiplicity m contributes a factor. That means the factor for the given polynomial function as x minus r the power of m. Or if x minus r the power of m is the factor of a certain polynomial function, then this real number that is r is said to be the root of the given polynomial function with multiplicity m times when m is any positive integer. And therefore, the given polynomial function could be f of x can be x minus 1 the power of 3 because just we are informed that 1 is the root of the given polynomial function with multiplicity 3 times. is the root of this polynomial function with 2 times, I mean multiplicity 2 times, so that x minus 2 the power of 2 must be the other factor of the given polynomial function. And lastly, we have x minus 3 because 3 is the root of this polynomial function with multiplicity 1 times. Therefore, the expected function, that's simply the function who is roots 1 to 3, and with this multiplicity could be f of x equal to x minus 1 the power of 3 times x minus 2 the power of 2 times x minus 3. ይህን expand ማድረግ እንችላለን. For example, if we are asked just to determine the degree of this polynomial function, the degree of the given polynomial function could be the sum of the multiplicities of the roots of the given polynomial function. ስለዚህ ይህ አሁን ዲግሪው ስንት ይሆናል ብንባል የእነዚህ የመልቲፕሊሲቲዎቹ ድምር ነው የሚሆነው ዲግሪው። ስለዚህ 3 አለኝ 2 5 እዚህ አንድ አለ 6 so that this could be a function with degree 6. Question number 15a. Use the rational root theorem to list all possible rational roots of this cubic polynomial function. ስለዚህ ራሽናል ሩት ቴረምን ማስታወስ ያስፈልጋል። እዚህ ጋር ራሽናል ሩት ቴረም ምንድን ነው የሚለው let f of x equal to this polynomial function with degree n and leading coefficient that's simply n and be a polynomial with integer coefficients if all the coefficients of the terms of the given polynomial function that are n minus 1 up to this constant term that is n what are positive integers, I mean any integer, so that the given polynomial function is said to be a polynomial function over integers. So that this will be a criteria for applying rational root theorem or simple rational root test. Then, if the given polynomial function that is f of x has a rational number which is written in the form of p over q, which is the root of f of x in lowest term. That means we know that this rational number could be in lowest term whenever the greater common divisor or simply greater common factor of p and q is equal to 1. Then the rational root of f of x must be of the form plus or minus factor of the constant term divided by the factor of the leading coefficient. ስለዚህ ጋር leading coefficient 2 አለኝ constant term 3 አለኝ። ስለዚህ ይሄ polynomial function rational roots ካሉት the possible rational roots of this polynomial function must be a rational number which is plus or minus the possible factors of the constant term that's 3 divided by the possible factors of the leading coefficient of this polynomial function which is 2. Therefore the rational roots could be this one that's plus or minus 1 plus or minus 3 plus or minus 1 over 2 plus or minus 3 over 2, which is the combination of the factors of the constant term which is 3 and the factors of the leading coefficient which is 2. Question number 15b, that is the next question. Apply the rational root theorem to find all rational roots of f of x equal to this cubic polynomial function and factorize the polynomial completely. Okay, the possible rational roots are, we know that in the first case the polynomial function is it is a polynomial function over integers ምክንያቱም ሁሉም ተርሞቹ ወይም ደግሞ ኮኤፊሽንቶቹ ኢንቲጀሮች ናቸው። ስለዚህ the constant term here is minus x, the leading coefficient is 1. ስለዚህ if we combine the possible factors of 6 with the possible factors of the leading coefficient of this polynomial function which is 1, the possible rational roots are becomes plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. ስለዚህ ይሄ ፖሊኖሚያል ፋንክሽን ራሽናል ሩቶች ካሉት እነዚህ ከስምንቱ ውስጥ አንዱ ሊኖረው ይችላል፣ ሁለት ሊኖረው ይችላል፣ ሶስት ሊኖረው ይችላል። ሁሉም ራሽናል ሩቶች ከሆኑ ማለት ነው። ስለዚህ ከሌለው ራሽናል ሩት ከሌለው ግን ከነዚህ ውጭም ቢሆን አይኖረውም ማለት ነው። so that these are the only possible rational roots of this cubic polynomial function. okay ከዚህ በኋላ ከነዚህ ውስጥ የትኞቹ ናቸው የሚሆኑ ስንል እነሱን ለመለየት ምንድን ነው ቼክ ማድረግ ነው። by substituting the individual possible rational roots in the place of x here, we can check whether the given rational number or simple roots or possible root can make the given polynomial function to be zero or none. ስለዚህ based on this fact, if we check 1 for example, f of 1 is exactly 0. If we substitute 1 here, we have 1 minus 6 plus 11 minus 6, which is 0, so that f of 1 0 ሆነ ማለት one of the possible rational root of this polynomial function is 1, and by using that factor theorem, if f of 1 is equal to 0, or simply remainder theorem, f of 1 is equal to 0, x minus 1 must be the factor of the given polynomial function. Therefore, if we divide this one and fully, the given polynomial function can be written as f of x equal to x minus 1 times x squared minus 5x plus 6. ይህ እንዴት ነው የሚገኘው? ይህን ፖሊኖሚያል ፋንክሽን f of x ን ለዚህ ሊኒየር ፋክተር x minus 1 ስናካፍል፣ ምክንያቱም x minus 1 የዚህ ፖሊኖሚያል ፋንክሽን ፋክተር ስለሆነ ሪሜንደር አይኖረውም። ስለዚህ f of x በዚህ ሊኒየር ፋክተር እና በዚህ ኳድራቲክ ተርም ወይም ደግሞ ፋክተር x squared minus 5x plus 6፣ ይሄ ማለት ይሄንን ለዚህ ለx minus 1 ስናካፍል የሚገኝ ኮሸንት ፖሊኖሚያል ፋንክሽን ማለት ነው። በዚህ መልክ ይጻፋል። And again, if we try to factorize again x squared minus 5x plus 6, we have this one that is x minus 2 times x minus 3. ያ ማለት ሁለት ሪል ነምበሮችን መፈለግ ነው። ስንደምራቸው minus 5 ስናባዛቸው ደግሞ positive 6 that are minus 2 and that are minus 3. Therefore, fully the factorized form of x squared minus 5x plus 6 could be this one. Therefore, the given polynomial function that is f of x can be expressed as x minus 1 times x minus 2 times x minus 3. Therefore, from the factorized form of this polynomial function, the roots of this polynomial function could be the zeros of the individual linear factors, so that x equal to 1, 2, and 3 would be the roots of this the zeros of the given polynomial function. That means when the roots are 1, 2, and 3 from this factorized form. Okay, next. 16a, find all rational roots of f of x equal to x cubed minus 4x squared minus 7x plus 10 and sketch the graph of the given polynomial function. ስለዚህ ጥያቄ ደግሞ ከቀደም እስካሁን ካየናቸው ምንድነው ልዩ የሚያደርገው? ራሽናል ሩቶቹን እንፈልጋለን። እንደገና ደግሞ በተጨማሪ ደግሞ we are asked just to sketch the graph of the given polynomial function. Therefore, first, the roots of the given polynomial function are, we know that fully the factorized form of this polynomial function could be f of x equal to x minus 1 times x minus 5 times x plus 2, so that the roots of this polynomial function could be x equal to 1, 5, and negative 2. And the roots are 1, 5, and negative 2, which are directly obtained from this linear factorization. But in order to draw the graph of the given polynomial function, we need to find the intercept, that is the x-intercept and the y-intercept. Actually, in the case of that of a polynomial function, the x-intercept of the graph of the given polynomial function means it is the point at which the graph of the given polynomial function is intersecting the horizontal axis or x-axis, and this pointers could be just the zeros of the given polynomial function. Therefore, the x-intercept of this polynomial function could be 1, 0, 5, 0, and negative 2, 0. Because the x-intercepts are the roots of the function, and its y-intercept is the constant term of this one. And therefore, the x-intercepts are minus 1, 0, 5, 0, and negative 2, 0. And its y-intercept could be, that is when x equal to 0, so that this expression will be 0 and only 10 will be left, so that 0, 10 would be its y-intercept. ያ ማለት ነው የዚህ ፖሊኖሚያል ፋንክሽን ግራፍ ኤክስ አክሱ እነዚህ ሶስት ፖይንቶች ላይ ቆርጧል፣ ዜሮዎቹ ላይ ማለት ነው። ዋይ አክሱን ደግሞ አንድ ፖይንት ላይ ብቻ ነው የሚቆርጠው። ማንኛውም ፖሊኖሚያል ፋንክሽን the constant term here is 10, so that 0, 10 would be its y-intercept. ሌላው እዚህ ጋር ስለ ፖሊኖሚያል ፋንክሽን ግራፍ በምናወራበት ጊዜ የፖሊኖሚያል ፋንክሽን ግራፍ ምንድነው ከተባለ it is the smooth curve, and the graphical or simply the turning point which አሉት the maximum number of turning point of the given polynomial function could be n minus 1 when n is the degree of the given polynomial function ስለዚህ ይሄ cubic polynomial function ስለተሰጠን የዚህ function graph ሁለት turning pointዎች ሊኖሩት ይችላሉ ቢያንስ አንድ ግን ይኖረዋል ኦኬ አንድ ሊኖር ይችላል ሌላ እነዚህ ይሄ ዲግሪ ወይም ደግሞ ሊዲንግ ተርሙ x the power of 3 that is the degree is 3 which is odd ስለዚህ ሁለቱ የፋንክሽናችን ሁለቱ ጫፎች በተቃራኒው አንድ ወደ ታች ሌላኛው ወደ ላይ ነው የሚወጣው ማለት ነው ኦኬ ስለዚህ based on this criteria ወይም ደግሞ ሌሎችን ቲፖችን እነዚህን ብናይ ለምሳሌ እዚህ ጋር ምን እናገኛለን end behavior ወይም ደግሞ the end points of the graph polynomial function determined by the leading term that is n times x the power of n ስለዚህ ለምሳሌ ይሄ ሊዲንግ ተርም ወይም ደግሞ የሊዲንግ ተርም ወይም ደግሞ የፋንክሽናችን ዲግሪው n ኢቭን ከሆነ ሁለቱም ጫፎቹ በአንድ አቅጣጫ ወደ ላይ ወይም ደግሞ ወደ ታች ነው የሚወጡት depending on the sign of the leading coefficient ፖዚቲቭ ከሆነ ሁለቱም ጫፎች ወደ ላይ ይወጣሉ leading coefficient ኔጌቲቭ ከሆነ ደግሞ ወደ ታች ናቸው ማለት ነው ነገር ግን ይሄ ዲግሪው n ኦድ በሚሆንበት ጊዜ አንድ ወደ ላይ አንድ ወደ ታች ነው የሚወጣው ስለዚህ የትኛው በግራ ያለው ወይስ በቀኝ በኩል ያለው ነው ወደ ላይ የሚወጣ ወይም ደግሞ ወደ ታች የሚወጣ የሚለውን it depends on the leading coefficient that's simply n okay ከዛ መልቲፕሊሲቲውን በምንመለከትበት ጊዜ if the given polynomial function has roots with multiplicity that is if the multiplicity that's simply k if k is even multiplicity so that the graph will bounces at the root ሩቱ ላይ ይነጥሩና ሳይቆርጠው ተመልሶ ወደ ነበረበት ከላይ የመጣ ከሆነ ወደ ላይ ይመለሳል ከታች ወደ ግራፍ ወይም ወደ ኤክስ አክሱ የሚመጣ ከሆነ ደግሞ ከነክቶት ወይም ደግሞ ሩቱን ኤክስ አክሱን ከነካ በኋላ ወደ ታች ይመለሳል ማለት ነው ኦድ በሚሆንበት ጊዜ ደግሞ ክሮስ ያደርገዋል ክሮስ አድርጎት ከታች መጥቶ ክሮስ አድርጎት ወደ ላይ ይወጣል ወይም ደግሞ ከላይ መጥቶ ከመጣም ደግሞ ክሮስ አድርጎት ወደ ታች ይወርዳል ማለት ነው መቼ when the multiplicity of the root of the given polynomial function that is k is 1 and it is odd so that the graph will have this property when it is odd and greater than or equal to that of 3 it flattens ከታች ከቤዙ ላይ ከታች የሚምጣ ከላይ የሚምጣ flat ይሆናል ወይም ደግሞ it becomes very flat or simply wide and the smoothness could be just the basic property of the graph of polynomial function it is the smooth that means the polynomial graph are continuous and smooth that means the graph doesn't have any gap or any sharp point or simply any hole even because it is smooth or simply continuous curve and the maximum turning point could be the maximum turning point could be a polynomial of degree n has at most n minus 1 turning points and the maximum number of the x-intercept or simply the roots of the given polynomial function could be that a polynomial degree n has at most n number of x-interceptors that means the number of x-interceptors is it could be identical with the number of the zeros of the given polynomial function ስለዚህ the maximum number of x-intercept could be this one ስለዚህ ነገር ግን አሁንም እዚህ ጋር ዲግሪው ኦድ ከሆነ የግድ አንድ x-intercept ይኖረዋል ዲግሪው ኢቭን ከሆነ ግን the graph of the given polynomial function totally either above the horizontal axis or below the horizontal axis so that the graph may not have an x-intercept but it must have the y-intercept which is obtained by letting x to be 0 so that these are the tips or simply the main thing that should be taken into consideration when we try to draw the graph of a certain polynomial function therefore based on this thing the graph of the previous function could be that is the graph of x cubed minus 4x squared minus 7x plus 10 could be look like this ስለዚህ አሁን እዚህ ጋር ስንት ተርኒንግ ፖይንት አለው የግራፍ የተሰጠን ፋንክሽናችን ዲግሪ 3 ነው ስለዚህ 3 ከሆነ at most n minus 1 3 minus 1 ሁለት ተርኒንግ ፖይንት አለው። አንደኛው ተርኒንግ ፖይንት እዚህ ጋር ነው። ሌላኛው እዚህ ጋር አለኝ። ሶስት ዜሮች አሉ። the roots are -2 I think +1 and +5። ስለዚህ እነዚህ ሶስት ፖይንቶች ላይ ግራፉ ኤክስ አክሱን ይቆርጣል ማለት ነው። ዲግሪው ኦርግ ስለሆነ አንደኛው ወደ ላይ ነው የሚወጣው። ሊዲንግ ኮኤፊሺየንቱ ፖዚቲቭ ነው። ስለዚህ በዚህ በቀኝ በኩል ያለው ወደ ላይ ይጨምራል፣ በግራ በኩል ያለው ደግሞ ወደ ታች ይቀንሳል ማለት ነው። so that this is the graph of this cubic polynomial function. Okay, next. A similar question, find all rational roots of f of x equal to 6x cubed plus x squared minus 4x plus 1, and we are asked just to sketch the graph of the same cubic polynomial function. ስለዚህ መጀመሪያ ሩቶቹን እንፈልጋለን። ፋክተራይዜሽን በኢዝሊ ፋክተራይዜብል ስለሆነ f of x can be factorized r to x minus 1 through x minus 1 times x plus 2. ስለዚህ definitely from the linear factorization the root of this cubic polynomial function could be this one, that is 1 over 2 from the first linear factor, 1 over 3 from the second one, and minus 1 from the third one. And next the intercepts ግራፉን ለማግኘት ደግሞ እንደምናደርገው ኢንተርሰፕት ያስፈልገናል። ከዛ the intercepts could be ዜሮቹን እዚህ ጋር ካገኘው ኤክስ ኢንተርሰፕቶችን ማገኘው ማለት ነው። ስለዚህ the x intercepts are 1 over 2 0, 1 over 3 0, minus 1 0, when 1 over 2, 1 over 3 and minus 1 are the zeros of the given polynomial function. ምክንያቱም የአንድ ፋንክሽን ግራፊካሊ የአንድ ፖሊኖሚያል ፋንክሽን ግራፍ የአንድ ፖሊኖሚያል ፋንክሽን ዜሮ ማለት የፖሊኖሚያል ፋንክሽኑ ግራፍ ኤክስ አክሱን የሚቆርጥበት ፖይንት ማለት ነው። ስለዚህ እነዚህ ኤክስ ኢንተርሰፕቶቹ ማለት እንደሱ ናቸው። ስለዚህ ዜሮቹ እነዚህ ከሆኑ የዚህ ፖሊኖሚያል ፋንክሽን ኤክስ አክሱን 3 ጊዜ ይቆርጠዋል ማለት ነው። and the points are 1 over 2, 1 over 3 0, and minus 1 0. And the x-intercept is every polynomial function has only one y-intercept, and this y-intercept will be obtained by letting x to be 0, so that is at the constant term. The constant term in this case is 1, so that 0 1 will be the y-intercept. Then the graph of the given polynomial function could be ይህን ይመስላል። the graph of this polynomial function will be this one. ስለዚህ ምን ብለናል? አሁን እዚህ ጋር ዲግሪው አሁንም እዚህ ጋር 3 ነው። ስለዚህ at most ሁለት ተርኒንግ ፖይንቶች አሉት። ይሄው አለው እዚህ ጋር 3 ሩቶች ነበሩት። ሶስት ሩቶች አሉት። ስለዚህ 3 ኤክስ ኢንተርሰፕቶች አሉት minus 1 1 over 2 and 1 over 3 የተቀራረቡት ለዛ ነው። This is 1 over 3, and this one is, I mean, this is first one maybe 1 over 2, and no, 1 over 3 and 1 over 2, so that these are the x-intercepts, and this end tends to infinity in the upward direction without any bound. This will tend to negative infinity without any bound again, so that the graph looks like this. Okay, next, find all rational roots of this polynomial function and sketch the graph. ተመሳሳይ ጥያቄ ነው። መጀመሪያ ሩቶቹን እንፈልጋለን። the roots by using factorization. The roots are this one, that is 5 from the first linear factor, 1 over 2 from this, and minus 3 from this one. ስለዚህ የዚህም ፖሊኖሚያል ፋንክሽን ሩቶቹን አገኘ ማለት ግራፉን ለመስራት የሚያስፈልገን ኤክስ ኢንተርሰፕቶችን ማወቅን ማለት ነው። So that the x-intercepts are 5 0, 1 over 2 0, and minus 3 0. The constant term is 15, so that it is y-intercept could be 0 15. Therefore, if we put this information on the Cartesian coordinate system, the graph of the given polynomial function will look like this. It is these are the x-intercepts. It has 2 turning points because the degree is 3. And its y-intercept could be this one, that is, it is just around 15 because it is 50. Therefore, the graph will have this property. Okay. Question number 17. identify the holes, asymptotes, intercepts, and domain of f of x equal to 4 over x square minus 3x minus 4 and then sketch the graph። አሁን ቅድም የፖሊኖሚያል ፋንክሽን ዜሮቹን እና ግራፉን ያየን። እዚህ ጋር ደግሞ ራሽናል ፋንክሽን ነው። ራሽናል ፋንክሽን ምን አለው? ሆሊን ሊኖሩት ይችላል፣ አሲምፕቶቶች ሊኖሩት ይችላሉ፣ ኢንተርሰፕቶች አሉት፣ ሊኖሩት ይችላል፣ ላይኖሩት ይችላሉ። ኢት ዲፔንድስ ዶሜን አለው። ስለዚህ ይህን ካወቅን በኋላ ምን እናገኛለን? እንደገና ደግሞ ወይም ተጠይቀናል we are asked just to draft or simply just to sketch the graph of the given rational function. ስለዚህ ከምን እነሳለን? first the domain is the set containing the whole set of real number without real number that can make the denominator to be 0. ስለዚህ x plus 1 x minus 4 these factors ስለሆኑ at minus 1 and minus 4 the denominator is 0, so that we should exclude minus 1 and positive 4 from being an element of the domain of this rational function. Okay. ስለዚህ አንዱ የፋንክሽናችን ግራፍ ስኬች ለማድረግ ወይም ደግሞ እዚህ ከተጠየቅነው አንዱ ጥያቄያችን ዶሜኑን አወቅን ማለት ነው። ሁለተኛው the vertical asymptote could be the vertical asymptotes are ይሄ ፋክቶራይዝ አልሆነም ከላይኛው ኦልሬዲ ኮንስታንት ስለሆነ ስለዚህ የታችኛው ዜሮቹ minus 1 እና 4 ከሆነ exactly x equal to 4 and x equal to minus 1 could be the vertical asymptotes for the graph of this rational function. Okay, then horizontal asymptote አለው። አንድ ፋንክሽን ራሽናል ፋንክሽን ሆሪዞንታል አሲምፕቶት የሚኖረው በሁለት ኬዝ ነው። አንደኛ የላይኛው ዲግሪ ከታችኛው በሚያንስበት ጊዜ ራሱ ኤክስ አክሲሱ ወይም ደግሞ y is equal to 0 ሆሪዞንታል አሲምፕቶት ይሆናል። በሁለተኛው ኬዝ ደግሞ የላይኛው ዲግሪ ከታችኛው እኩል በሚሆንበት ጊዜ the horizontal asymptote for the graph of the given rational function could be the line, the horizontal line. That means when y is equal to the quotient of the leading coefficients of the numerator and the denominator. ስለዚህ በዚህ መልኩ ይህንን በምንመለከትበት ጊዜ የላይኛው ዲግሪ 0 ነው፣ ታችኛው 2 ነው። ስለዚህ የላይኛው ዲግሪ ከታችኛው ስለሚያንስ y is equal to 0 ወይም ደግሞ x አክሱ ራሱ ለዚህ ራሽናል ፋንክሽን ሆሪዞንታል አሲምፕቶት ነው ማለት ነው። ይሄ ፋንክሽን ኦብሊክ አሲምፕቶት የለውም። ምክንያቱም ኦብሊክ አሲምፕቶት አንድ ራሽናል ፋንክሽን የሚኖረው መቼ ነው? የኑሜሬተሩ ዲግሪ ከታችኛው ከዲኖሚኔተሩ ዲግሪ በአንድ ሲበልጥ ነው። ስለዚህ ይሄ የላይኛው ከታችኛው ስለሚያንስ ኦብሊክ አሲምፕቶት አይኖረውም። ቨርቲካል አሲምፕቶት 2 አለው። ሆሪዞንታል አሲምፕቶት y is equal to 0 አለው፣ ወይም ደግሞ x አክሱ ራሱ ሆሪዞንታል አሲምፕቶት ነው ማለት ነው። and the y-intercept could be the y-intercept is that means the y-intercept could be when x equal to 0. I think it is an error. This is an error. The x-intercepts, oh, it doesn't have, I think, no x-intercepts, and okay, yeah, y-intercept, it doesn't have any y-intercept. That's simply when the y-intercept means when y is equal to 0. 4 over x squared minus 3x is equal minus 4 doesn't have any 0, so that this rational function or the graph of this rational function doesn't intersect the x-axis. ምክንያቱም ኦልሬዲ እዚህ ጋር x-axis ምንድነው ብለናል? ሆሪዞንታል አሲምፕቶት ነው። and the y-intercept could be when x equal to 0 it becomes 4 over minus 4 which is minus 1, so that 0 minus 1 will be the y-intercept. ስለዚህ የዚህ ፋንክሽን ግራፍ y-አክሲሱን 0 ኔጌቲቭ 1 ላይ ይቆርጠዋል ማለት ነው። ስለዚህ አሁን እዚህ ጋር ምን አገኘን? y-intercept ዶሜን አገኘን፣ ኢንተርሰፕቶቹን አወቅን፣ ኦብሊክ አሲምፕቶት የለውም። so that the graph would be ይህን ኢንፎርሜሽን ካርቴዥያን ኮኦርዲኔት ሲስተም ላይ ካስቀመጥን በኋላ if we see the property of the graph of the given rational function near the asymptotes, we can have the graph of the given rational function will looks like this. ስለዚህ the vertical asymptote y is equal to x equal to 1, minus 1, and this is x equal to 4. ስለዚህ ይሄ ግራፍ ይሄ ማለት when x approaches minus 1 from the left side, so that the functional value of the given function will tend to in the positive infinity. ምክንያቱም እዚህ ጋር ከዚህ ከማይነስ ወይም ደግሞ ማይነስ ኤክስ ከማይነስ ቱ በዚህ በግራ በኩል ወደ ማይነስ ዋን በሚጠጋ ጊዜ ይህ ፋንክሽናል ቫልዩ ወይም ደግሞ ፋንክሽኑ 4 over x square minus 3x minus 4 will tends to positive infinity so that the graph will goes in the opposite direction, approaches from the left side. Similarly, when x go to that of negative infinity, when x go to negative infinity, ይሄ በጣም ትልቅ ኔጌቲቭ ትንሽ ኔጌቲቭ ነገር ግን በአብሶሉት ቫልዩ በጣም ትልቅ ቁጥር በሚሆንበት ጊዜ this one that simply ይሄ ላይኛው አይጨምርም አይቀንስም ኮንስታንት ነው። ነገር ግን ታችኛው ኔጌቲቭም ቢሆን ይጨምራል በጣም። ስለዚህ a constant term divided by a very small negative number with very large in absolute value will tends to there or simply will approach the x-axis or simply the horizontal asymptote of the graph of the rational function. በዚህ በኩል ባለው ወይም ደግሞ x equal to 4 የሚለው vertical asymptote ስንመጣ ራሱ ነው። That means when x approaches positive 4 from the left side, the graph will, or simply the functional value will tend to positive infinity, so that the graph will have this property. But when x goes to that of positive infinity, ይሄ በጣም ትልቅ ፖዚቲቭ ቁጥር በሚሆንበት ጊዜ x square minus 3x minus 4 በጣም ትልቅ ፖዚቲቭ ቁጥር ይሆናል። ስለዚህ ይሄን ኮንስታንት ለዚህ ትልቅ ፖዚቲቭ ቁጥር በምናካፍልበት ጊዜ it approaches to zero, or it approaches the horizontal axis, that's simply the x-axis, from above, so that the graph will looks like this. ስለዚህ በእነዚህ በሁለቱ መካከል በሁለቱ ቨርቲካል አሲምፕቶቶች መካከል ያለውን ፕሮፐርቲ በምንመለከትበት ጊዜ እንደዚህ አይነት ከርቭ ይሆናል። y intercept that is simply 0 minus 1 is this one, so that the graph totally looks like this. Okay, next. Again, and that is similar question with similar rational function. ሆል ተጠይቀናል፣ አሲምፕቶት፣ ኢንተርሰፕት እና ዶሜን የተጠየቅነው እዚህ ጋርም። ከዛ መጨረሻ ላይ graph of the given rational function. The function is f of x equal to x square minus 9 over x square minus x minus 6. ይሄ ፋንክሽን አሁን ምኖች አሉት ከተባለ ያው ዶሜን ይኖራል፣ ዶሜን አለው። ፋክተራይዝ በምናደርግበት ጊዜ መጀመሪያ ፈርተር ሲምፕሊፋይ ብናደርግ we have this one, that is x square minus 9 could be the factorized form of the denominator could be x minus 3 times x plus 3, and the denominator could be ስንደምራቸው minus 1 እና ስናባዛቸው minus 6 የሚሰጠን minus 3 and substitute, so that this could be x minus 3 times x plus 2. ስለዚህ further simplify ስናደርግ we can this one that is simply x minus 3 ይሄ ጠፋና x plus 3 over x plus 2 ይሆናል። But this could be equivalent to that of this one when x is different from that of zero. ምክንያቱም ሁለት ፋንክሽኖች ኢኩቫለንት የሚሆኑት ተመሳሳይ ዶሜን ሲኖራቸውና ፋንክሽናል ቫልዩአቸውም እኩል ሲሆን ስለሆነ ስለዚህ እናገኛለን። ከዛ እዚህ ጋር x minus 3 እና x minus 3 ይሄ ጠፍቷል። ስለዚህ minus 3 must not be within the domain of this rational function. ስለዚህ minus 3 ላይ ምን ይኖረዋል? ይሄ polynomial function whole ይኖረዋል ማለት ነው። so that the whole could be, if we substitute minus 3 here, I mean minus 3 for x, I mean positive 3 for x, 3 plus 3 is 6, 3 plus this one is 0, I mean 5, so that 3 6 over 5, 3 6 over 5, okay, 6 over 5 could be the whole. ይህ ፋንክሽን ሆል ይኖረዋል 3 6 5ኛ ነው። ይሄ ሆሉን ለማግኘት ኦሪጂናል ይህ ፋንክሽኑን አይደለም ነው። ስለዚህ ጋር ከወሰድን አንዲፋይንድ ነው የሚመጣው ምክንያቱም ዲኖሚኔተር ዜሮ አት 3። ስለዚህ ሲምፕሊፋይድ ፎርሙም ይሄን ፋክተሮችን ካንስል ካደረግን በኋላ አፍተር ካንስሌሽን የምናገኘው ሲምፕሊፋይድ ፎርሙን ተጠቅመን የፋንክሽኑን ሆል የራሽናል ፋንክሽኑን ሆል እናገኛለን። ስለዚህ ሶልቭ ለማድረግ ሆል ያለው 3 ላይ ነው። 3ን እዚህ ጋር ሰብስቲቱት ስናደርግ 6 over 5 እናገኛለን። ስለዚህ 3 6 over 5 on the first quadrant, that means ይሄ polynomial function, I mean rational function ሆል ይኖረዋል ማለት ነው። ኦኬ ሌሎቹ vertical asymptote ስንል ደግሞ vertical asymptote ማለት vertical line which cannot be intersected by the graph of the given rational function ከዶሜኑ ኤክስክሉድ ያደረግናቸው ፖይንቶች ወይም ደግሞ ሴት ኦፍ ነምበርስ ካሉ ፕሮባብሊ ቨርቲካል አሲምፕቶት ሊኖር የሚችለው እነሱ ጋር ነው። ስለዚህ ኤክስ ኢኳል ቱ ማይነስ ቱ is the only vertical asymptote for the given rational function። ሆሪዞንታል አሲምፕቶቱን በምንመለከትበት ጊዜ ደግሞ ምክንያቱም እዚህ ጋር የተሰጠን ፋንክሽን የላይኛው ዲግሪ እና የታችኛው ሁለቱ እኩል ናቸው። ስለዚህ እኩል ከሆነ ሆሪዞንታል አሲምፕቶት ይኖረዋል። ይህ ሆሪዞንታል አሲምፕቶት ደግሞ የሁለቱ የኒውሜሬተሩ እና የዲኖሚኔተሩ ፖሊኖሚያል ፋንክሽኖች ሊዲንግ ኮኤፊሽንት ይሆናል ማለት ነው። ስለዚህ ሁለቱም ተመሳሳይ ኮኤፊሽንት ነው ያላቸው ሊዲንግ ኮኤፊሽንት ነው ያላቸው and therefore y equal to 1 over 1 or simply y equal to 1 will be the horizontal asymptote for the graph of the given rational function። ኦብሊክ አሲምፕቶት አይኖረውም። ሌላው ኤክስ ኢንተርሰፕቱን በምንወስድበት ጊዜ ኤክስ ኢንተርሰፕቱ ማለት ቶታሊ የራሽናል ፋንክሽኑ ዜሮዎች ማለት ነው። የራሽናል ፋንክሽኑ ዜሮ ማለት ነው። የራሽናል ፋንክሽን ዜሮ ማለት ደግሞ ኒውሜሬተሩን ዜሮ የሚያደርግ ዲኖሚኔተሩን ግን የማያደርግ ማለት ነው። so that the zero of the numerator are positive 3 and positive 3 ነገር ግን positive 3 or minus 3 cannot make the denominator to be 0. ስለዚህ but 3 can make the denominator to be 0 so that 3 አይሆንም። ነገር ግን minus 3 could be the zero of this the rational function so that 3 0 could be minus 3 0 could be the x-intercept of the given polynomial rational function። y-intercepቱን ለማግኘት xን ቶታሊ 0 ማድረግ ነው። 0 ስናደርግ ምንድነው የምናገኘው? ይህ 0 ሲሆን we have minus 9 over minus 6 which can be further simplified to 3 over 2 so that 0 3 over 2 would be the y-intercept of the graph of the given rational function። ኦኬ ከዛ ዶሜኑ ምንድነው የሚሆነው? ታችኛው 0 ከሚያደርጉትን ኤክስክሉድ ስናደርግ set of real number except minus 2 and positive 3 could be the domain of this rational function. And then the graph will be if we put this information on the Cartesian coordinate system, we have the graph which looks like that of this one. A horizontal asymptote አለኝ and vertical asymptote አለኝ which is x equal to negative 2 and this is the y-intercept that is 0 or 3 over 2. They hit the x-intercept which is minus 3 0 so that the graph of the given rational function looks like this. You can observe the property. Okay. Again, similar question. Identify holes, asymptotes, intercept and domain of f of x equal to x squared plus 2x minus 3 over x squared minus 1 and then sketch the graph. ስለዚህ መጀመሪያ ሲምፕሊፋይ ማድረግ አለብን። ምክንያቱም ካንስል የሚደረጉ ተርሞች ካሉ እነሱ ማወቅ አለብን። ስለዚህ ዲኖሚኔተር can be factorized as x plus 3 times x minus 1 and the denominator is x minus 1 times x plus 1. ስለዚህ x minus 1 therefore the simplified form of the given rational function could be x plus 3 over x plus 1 when x is different from 1. okay ስለዚህ አሁን እዚህ ጋር ምን አለኝ? እዚህ at minus 1 ላይ ወይም ደግሞ at 1 when x equal to 1 ይሄ rational function vertical asymptote ሳይሆን ሆል ነው ያለው ማለት ነው። ስለዚህ the whole could be ይህን simplified form ነው የምንጠቀመው። አንድ ስንተካ እዚህ ጋር we have 1 plus 3 that is 4 1 plus 1 is 2 4 over 2 will be 2 so that 1 2 ላይ ሆል ይኖራል ማለት ነው rational function። ኦኬ ከዛ አሲምፕቶቶችን ስናይ x equal to minus 1 ብቻ ነው vertical asymptote የሚሆነው። ሆሪዞንታል አሲምፕቶቱን ስናይ አሁንም ይሄ ሆሪዞንታል አሲምፕቶት አለው ምክንያቱም ዲግሪያቸው እኩል ነው። ስለዚህ የሊዲንግ ኮኤፊሽንቶች አንዳንድ ነው so that y is equal to 1 is said to be the horizontal asymptote for the graph of the given rational function. ኦብሊክ አሲምፕቶት የለውም፣ ምክንያቱም የላይኛው ዲግሪ ከታችኛው በአንድ ስለማይበልጥ እኩል ስለሆኑ ኦብሊክ አሲምፕቶት የለውም። the intercept could be the zeros of the rational function, that is minus 3, which is minus 3 0 could be the x-intercept, and the y-intercept could be just if we let y to be, the x to be 0, 0 3 will be its y-intercept. So that the domain could be the set containing set of real number without minus 1 and 1. Then the graph will be this one. This is the vertical asymptote. They hit the y-intercept. They hit the x-intercept, which is minus 3 0, and this one is 0 3, and this one is y is equal to 1, the horizontal asymptote. So that totally the graph of this rational function, which is x squared plus 2x minus 3 over x squared minus 1 will looks like this. Okay, the next question. Sketch the graph of f of x equal to x squared plus 11x plus 18 over 2x plus 1, showing all important features here. ፊቸሮች እናያለን። አሁን እዚህ ጋር ምንድነው ከቅድሙ ለየት ይላል። ያው ግራፍ ነው ግን ከቅድሙ ይለያል። የቅድሞቹ እስካሁን ያየናቸው ምንድነው ቨርቲካል አሲምፕቶት እና ሆሪዞንታል አሲምፕቶት አላቸው። ኦብሊክ አሲምፕቶት የላቸው። ይሄኛው ኦብሊክ አሲምፕቶት አለው፣ ሆሪዞንታል አሲምፕቶት የለውም። ስለዚህ ኦብሊክ አሲምፕቶት ለምንድን ነው የሚኖረው? ምክንያቱም የላይኛው የኖሚኔተሩ ዲግሪ 2 ነው፣ የዲኖሚኔተሩ 1 ነው። ስለዚህ የላይኛው የታችኛውን ዲግሪ በአንድ ይበልጠዋል። so that the graph will have an oblique asymptote። ስለዚህ ኦብሊክ አሲምፕቶቱ እንዴት ይገኛል፣ አሲምፕቶቶቹን ኢንተርሰፕቶቹ እንዴት ይገኛል፣ ሌሎች አሲምፕቶቶቹ ሳሉት ወይ የሚለውን እናያለን ማለት ነው። ስለዚህ the denominator cannot be zero። ስለዚህ ይሄ ዲፋይን እንዲሆን ይሄ it must be non-zero so that but the denominator to x plus 1 is 0 when x equal to negative 1 over 2. Therefore, the domain could be a set of real number without negative 1 over 2. They hit the domain. Because the domain is very important for the graph of the given rational function. ስለዚህ ይሄን ዶሜኑን በዚህ መልኩ ካገኘን ፕሮባብሊ ይሄ ቨርቲካል አሲምፕቶት ካለው x equal to negative 1 over 2 ነው ሊሆን የሚችለው። ስለዚህ አለው ወይስ የለው የሚለውን በምንድን ነው የምናውቀው? ሲምፕሊፋይ እናደርግና ፋክተራይዝ አድርገን ይሄ 2x plus 1 የሚጠፋ ከሆነ ሪሙቬብል ፋክተር ከሆነ ሆል ነው እንጂ ቨርቲካል አሲምፕቶት አይኖረው ማለት ነው። ስለዚህ after factorizing the numerator we have the factorized form of the numerator is this one. ስለዚህ 2x plus 1 ሊጠፋ የሚያጠፋው ፋክተር የለውም። therefore hence the polynomial function that is f of a can be expressed as x plus 2 times x plus 9 over 2x plus 1 over 2x plus 1. Then if I set the numerator equal to 0, that is x plus 2 plus times x plus 9 is equal to 0, so that the zeros are minus 2 and minus 9. And thus the x-intercepts could be, ምክንያቱም የአንድ የራሽናል ፋንክሽን ዜሮች ማለት የራሽናል ፋንክሽኑ የግራፉ ኤክስ ኢንተርሰፕቶች ማለት ናቸው። ስለዚህ ማይነስ 2 0 እና ማይነስ 9 0 ላይ የዚህ ራሽናል ፋንክሽን ግራፍ ኤክስ አክሽን ይቆርጣል። ዋይ ኢንተርሰፕቱን ለማግኘት we need to set x to be 0። ስለዚህ x 0 ሲሆን ምን እናገኛለን? we have 18 because the function here is this is 0 times 0 plus 18 over 0 plus 1, that is 18 over 1, which is 18. Therefore 0 18 could be the y-intercept of the graph of the given function. This is the y-intercept, and the function could be the function that is x plus 2 plus times x plus 9 over 2x plus 1 has the vertical asymptote x equal to negative 1 over 2. It has an oblique asymptote. Oblique asymptote ለማግኘት ምንድነው የምናደርገው? using long division method ማካፈል ነው። አካፍለን ኮሸንቱ ማለት it must be linear polynomial function. That linear polynomial function could be used as an oblique asymptote for the graph of the given rational function. ስለዚህ ይህን ስናደርግ ምንድነው የምናደርገው? since the degree of the denominator is 1 more than the degree of the denominator, it has an oblique asymptote, and this oblique asymptote will be obtained by performing or simply applying long division method. So when we divide x squared plus 11x plus 18 by the denominator, that is 2x plus 1, we have ለምሳሌ መጀመሪያው x squared የዚህ ሊዲንግ ተርም ለዚህኛው ስናካፍል ምናገኛለን? x over 2 እናገኛለን። ከዛ x over 2 በዚህ በዲኖሚኔተሩ 2x plus 1 አባዝተን የዚህ ፕሮዳክት ከዚህ ኳድራቲክ ተርም ላይ በምናቀንስበት ጊዜ we have this one, that is x squared minus this product will give us 21x over 2 plus 18. ስለዚህ ይሄ እዚህ ስቴፕ ላይ ያገኘነው ሪሜንደር ነው ማለት ነው። ነገር ግን አሁንም ማካፈላችንን እንቀጥላለን፣ ምክንያቱም እዚህ ያገኘነው ሪሜንደር ዲግሪ አንድ ነው። ስለዚህ የምናካፍለውም ለዚህ ሊኒየር ስለሆነ we have to divide። ስለዚህ ለማካፈል ምንድነው የምናደርገው? የዚህን የአዲሱን ሪሜንደር ሊዲንግ ተርም 21x over 2 ለ2x እናካፍለዋለን። ስለዚህ ስናካፍል እናገኛለን we have this one, that is 21 over 4። ከዛ 21 over 4ን ለዲኖሚኔተሩ በ2x plus 1 እናባዘዋለን። ስለዚህ ስናባዛ እናገኛለን። አሁን ይሄንን ከቅድሙ ሪሜንደር እንቀንሳለን ማለት ነው። that means 21x over 2 plus 18 minus 21x over 2 plus 21 over 4. ስለዚህ 21x over 2 21 over 2 ይሄ ይጠፋና 18 minus 21 over 4 could be exactly equal with 51 over 4. So that exactly 51 over 4 will be the remainder 4 which is obtained here. ስለዚህ ኮሸንቱ ምን ይሆናል ሲባል መጀመሪያ ላይ ምን አግኝተናል? x over 2 አግኝተናል። ከዛ እዚህ ጋር 21 over 4 አግኝተናል። therefore or then given polynomial function using polynomial division algorithm, f of x can be expressed as x over 2 plus 21 over 4 plus 51 over 4 over the denominator, that is 2x plus 1. ስለዚህ ይሄ polynomial function, this linear polynomial function, that is simply this one, could be considered as an oblique asymptote for the given rational function. oblique asymptote ይሄ ኮሸንት ነው። ይሄኛው ሪሜንደር ነው። ይሄ ዲቫይደር ነው። ስለዚህ this is the linear equation, or simply linear polynomial function, which can be used as an oblique asymptote for the graph of the given rational function. Okay, and then the next one could be that is the oblique or slant asymptote could be okay እዚህ እንዳሳያችሁ ይሄ ነው የሚሆነው። ኦብሊክ አሲምፕቶት ይሄ ነው። ወደ ውስጥ ለገባ በደንብ አይታይም። y is equal to x over 2 plus 21 over 4 will be the y-intercept, the oblique or simply the slant asymptote of the graph. Then the function that is f of x given to be this one, then near the vertical asymptoቶቹ ምን ይመስላል ወይም ደግሞ ፕሮፐርቲው ምንድነው የሚመስለው የሚለውን ለማየት near the vertical asymptote እንግዲህ በዚህ ማለት x equal to -1 over 2 የፋንክሽኑ ግራፍ በቀኝና በግራ በኩል ምን ይመስላል? ለምሳሌ from the left side, that means when x approaches -1 over 2 from the left side, በዚህ በኩል በሚመጣ ጊዜ this one, that is simply 2x plus 1, will approach to that of 0, and this 0 could be from the negative side, so that ይሄ ምን ይሆናል ማለት ነው? It tends to be negative ነው, so that a constant divided by a very small negative number 2, which is closer to that of 0 from the left side, is said to be a very small negative number with a very large in absolute value, so that f of x will tend to negative infinity. ስለዚህ በግራ በኩል ይሄ x -1 over 2 በሚቀርብ ጊዜ ይሄ ምን ይሆናል? ወደ 0 ይጠጋል from the negative part, or ደግሞ from the left side። ስለዚህ ኮንስታንት በጣም ትንሽ ለሆነ ለዜሮ ቅርብ የሆነ ቁጥር ነገር ግን ለሆነ ኔጌቲቭ ቁጥር በምናካፍልበት ጊዜ ከምናገኘው በጣም ትንሽ ኔጌቲቭ ወይም ደግሞ በአብሶሉት ቫልዩ በጣም ትልቅ ቁጥር ስለሆነ f of x will approaches to negative infinity to the left side of the vertical asymptote. በቀኝ በኩል from the right side when x approaches negative 1 over 2 from the right side f of x will tend to positive infinity ምክንያቱም በዚህ በቀኝ ስንወስድ ከኔጌቲቭ 1 over 2 የሚበልጥ ቁጥር ላይ x በምንተካ ጊዜ ይሄ አሁንም ወደ ዜሮ ነው ቴንድ የሚያደርገው ነገር ግን from the positive part ወይም ደግሞ from the positive side ስለዚህ ኮንስታንት በጣም ትንሽ ለሆነ ለዜሮ ቅርብ የሆነ ትንሽ ፖዚቲቭ ቁጥር በምናካፍልበት ጊዜ we can obtain a very large positive number. So that in this case, f of x will tend to negative infinity. Therefore, they hit the property of the graph of the given rational function near the vertical asymptote. Then, the graph of the given rational function could be this one. The vertical asymptote is this one, which is x equal to x is equal to negative 1 over 2. They hit the oblique asymptote, which is y is equal to x over 2 plus 21 over 4. And they hit the y-intercept. That is, the y-intercept means x is equal to 0, 18. And the x-intercept could be ሁለት x-intercepቶች ናቸው ያሉት ብለናል። እነሱ ምንድን ናቸው? እዚህ ጋር the x-intercept could be the zeros of the given polynomial function. That means x is equal to -9 and -2, so that the graph will look like this. The graph will look like this. Okay, that is all what I have for this video. Okay, አመሰግናለሁ። ያው ይህንን ቪዲዮ ላይክ፣ ሼር እና ሰብስክራይብ ማድረግ አትርሱ። ለጓደኞቻችሁም ሼር ማድረግ፣ ኮሜንት ማድረግ ብታደርጉም ደስ ይለኛል። አመሰግናለሁ።